So for my activity lesson video, I actually chose one of my activities from my problem, or from, excuse me, my Project 1 paper that I thought demonstrated the most amount of problem solving skills and things like that. So this is a lesson that would be used in Algebra 2. That's one of them that I'm going to be teaching next year. Again, a lot of my students, I know I mentioned this in the past, a lot of my students are very low, and so I feel like this is a really good class to take a stab at trying some more problem-solving approaches to things, so that I don't have to just give them formulas and things like that, so that they don't know how to do it or don't know how to apply things, but rather to do some problem-solving approaches to figuring out important information. And for this topic, I actually chose some graphing quadratic functions and parabolas. In my opinion, I think that's one of the most important parts of Algebra 2 and something that students really need to know how to do. I mean, there's other important parts of Algebra 2, but I feel like if you're able to, if you think about Algebra 1, it's the ability to figure out functions and graph linear equations. Algebra 2 is mostly graphing quadratic equations, quadratic functions. So it's actually, my learning objective is one of our state standards. So 921 is parabolas, asymptotes, and graphs. And specifically, I'm looking at benchmark 9215, which is identifying the vertex, line of symmetry, and intercepts of parabolas corresponding to quadratic functions. And it says symbolically or graphically. Now, in my opinion, students are a lot better doing it graphically because they see it and they can kind of, figure out the important stuff that way. But what I'm going to try and take the problem-solving approach to is using the graph to solidify how to do it equivocally, or using it more symbolically, or using the equations. Okay, so for students to be mastered at this learning objective, they'll have to be able to find the three important values, or three important things: vertex, line of symmetry, and the intercepts. So x-intercept, y-intercept. Find the values of the vertex, line of symmetry, and intercepts from the equation, and to find it for all three forms, which would be standard form, vertex form, and factored form. And so my hope is that I'll actually help the kids by looking at all three forms of the same function. So it'll just be written differently, and hopefully they'll be able to figure out what's important from it. So I have two things that I want them to look at. So the first thing I want them to look at is this function, f of x is equal to x squared plus 2x minus 8. And what I put in my paper was that I would want kids to see it in the standard form of the quadratic function, because that's the most common that kids are going to see. And that's how we're going to want kids to graph it mostly. So if we look at that one right there, I have it graphed in green. Okay, so this is graphed in green, and this is the function x squared plus 2x minus 8. Okay, so we would, the important questions I would want students to answer while looking at this is find the y-intercept or intercepts, x-intercept or intercepts, axis of symmetry, and vertex from the graph. Okay, we might have to talk about what those are, but just say, okay, so the x-intercept they should be able to find pretty easy. Okay, so it's the point -4, 0, and the point 2, 0. Okay, and write those down. Then the y-intercept, again, they should find it pretty easy. They know what x-intercepts and y-intercepts are, 0, -8. And we talk about, okay, so vertex. What's the vertex? Well, the vertex is basically that point where my parabola changes direction. Okay, so here it's -1, -9. And so then the axis of symmetry would be like a line that extends along this vertex, and basically it mirrors itself on both sides. So for this one, it would be x equals -1. Okay? And so we'd say, well, so if I look at this function right here, x squared plus 2x minus 8, what's something that you notice about it? Okay, well, what's something about the values that we found, these, three important values, okay, three things: vertex, intercepts, okay, and axis of symmetry. Can you find any of those from the function? Okay? And let them talk about it, let them discuss it with a partner or a group, and just see what they come up with. Probably my guess is that they'll notice, okay, well, the y-intercept, just like in a linear function, is going to be the end right there. So -8, I know that my y-intercept is at 0, -8. Okay? So then after we've done that and we've talked about it a little bit, I'd say, okay, well now I got a new function for you to look at. Okay? It's going to be x plus 4 times x minus 2. And you look at this one right here and they say, well, it's the exact same. You say, okay, so what do you notice about it? Okay, well, again, the intercepts are the same, negative 4, 0, 2, 0. Y-intercept is negative 8. And the vertex is going to be negative 1, negative 9. Axis of symmetry is x equals negative 1. And you say, okay, well now look at this function right here, and what do you notice about it compared to the values you have? And again, discussion would come up, and I bet they would say, okay, well, I see that I have positive, or x plus 4, and one of my intercepts is negative 4, 0. And I have another, one of my factored form, x minus 2, and it's 2, 0. So we could say, okay, well, maybe that has something to do with it, and maybe that's important. Or maybe they would notice, okay, 4 times negative 2 is negative 8, and so maybe that has something to do with my y-intercept. Okay, sounds good. Let them talk it over, let them discuss it. And say, okay, I got one more version of it, of the same function for you. Here it's graphed in black. It's x plus 1 quantity squared minus 9. And they'd say, okay, well, look at that, and they'd say, well, that one's kind of nice because now they actually give me, the vertex. I got the numbers from the vertex. The minus 9 is the negative 9 in my vertex point, and, plus 1 is like the opposite of negative 1. Maybe that's important. You can kind of talk about, okay, so, does negative 4 and 2 ever show up with it? Well, not in this form. Or how about negative 8? Well, not in this form, right? And so just kind of let them mull it over a little bit, talk about it, probably have them journal a little bit, and just kind of see what they know about it. And say, okay, so now let's look at a different problem. Okay, let's look at a different problem. So you got some ideas. Let's look at a different problem. And so we'd say, okay, well, here's another one. Okay, so first I give you the form when it's in standard form. Now, the funny thing about this one, or the ironic thing about this one, is now we're starting to work with fractions. And hopefully your kids are not like mine, but my kids hate fractions. They absolutely despise them. They will do anything in their power to not do fractions. They will change everything to decimals. Okay? So, if this is the case, though, and I look at this one, x squared minus 3 halves x minus 5 halves. Okay? And I say, write down the important information. Okay? So the vertices, the x-intercepts, or the roots in our case, would be negative 1, 0 and 2.50. Okay? That, doesn't help out very much. They'd probably be able to say, okay, well, negative 5 halves is the same as negative 2.5, because, again, they don't like fractions. They'll say it as a decimal. So I'm able to find the y-intercept pretty easily on that one. Okay, that's good. And then, say, I get the vertex, and they look at that and go, I have no idea how we get that. No idea. I have no idea how we get, 0.75 or 3/4, and then negative 3.063 to them would just be, something very arbitrary. They wouldn't know what that is. And I say, okay, so we talk about it a little bit, see if they're able to do anything with it. And then I say, okay, well, now I'm going to give you the factored form, and here it is again. And they'd say, okay, so I see x minus 2.5, so that would mean that probably one of my x-intercepts is 2.50, which we knew it was, okay? And they'd say x plus 1, and hopefully that they'd be able to find that, okay, so that's negative 1, 0. Again, hopefully they're seeing those things, they're seeing the correlation between them. And then I'd say, okay, well, does that help you find the y-intercept? Yeah, that helps me, because I do negative 2.5 times 1 is negative 2.5. My y-intercept is, the point 0, negative 2.5. So finally, the vertex, again, they would have probably not sure how we get that number, okay? I say, well, now let me give you the vertex form. And they'd say, okay, so I look at this, well, maybe they would know at this point. I'd have to look through my curriculum. But my guess is that they're going to know how to complete the square. So they're going to look at this one and say, okay, well, if I took the first version, okay, the first version right here, x squared minus 3 halves x minus 5 halves, and I completed the square, I could probably get down to this, the vertex form. And when you do that, all of a sudden now you find the vertex. And so my hope is that by doing it this way, by applying some of our problem-solving methods, Schoenfeld says that if you look at an easier problem, or you look at the diagram, or you draw a diagram, that suddenly, hopefully, your problem solving will happen throughout, and that our students will be able to pick out the important things. And so my hope by doing it this way is that if I have the kids look at all three versions of the same graph, they'll be able to, okay, if I look at the standard form, I'll be able to find the y-intercept. Okay, that's good. If I find the factored form, because again, at this point, I'm assuming that they'll be able to factor these out. Okay, factor it out. Okay, now I can find not only the y-intercept but the x-intercepts. Okay, so that's good. So of that, what's the only thing we have to do left? Well, if you go back to the original form and you complete the square, you all of a sudden get this, which is now the vertex. And so now they found all three important things because the axis of symmetry, we would say, okay, it's just a straight line. X equals whatever the x coordinate in our vertex is, that they'd find that important thing. Okay, they'd find that what we want them to find, and they'd notice that between the three versions, there's important information that we can find. And so, if I wanted to extend this, and one of the aspiration goals that I have is that we would talk about foci a little bit more, or the focus of this graph. And doing it this way, it would have to be for some of my students who are really, pretty gung-ho and could see this really fast. Then we could talk about, what is the focus of this graph? What's the directrix of this graph? And, how could I find them if I had just the standard form? Or how could I find them if I had just the factored form? Or how could I find it if I had just the vertex form? And my hope is that by teaching it this way, I don't make them memorize formulas of how to find those important things, but rather see that between the three versions of the same function, we're able to pull out the important information. And that way, it's hopefully a little bit more lasting. And so if we say, okay, so if they give you one version of this graph, or one version of this function, let's put it in the other two, and that way, we can find all the important information without having to graph. I think that's a pretty good approach to problem solving. So then my extension to the lesson, or what I would do after we've talked about this and we've done it, I'd give the students a couple practice problems. And the thing I noticed about these practice problems, the first one, okay, right here, if you notice the first one, x squared minus 8x plus 13, that looks very similar to what they've done before. You say, okay, well, let's try and figure out some things. Now, the goofy thing about this one, obviously 13 is a prime number, so they're going to have a hard time maybe trying to factor it. So we talk about what are some things we can do there. Okay. The next one, 3x squared plus 42x plus 49. What do we notice about that one? Well, that one has a 3 in front of it. We could talk about some things about that. Next one, 1/3, okay? Now it's a fraction. Oh, again, we hate fractions. But we talk about what can we do there to change from form to form. Okay? Then I give them a vertex form of something they haven't seen before, -2. And so my hope is then again applying those problem-solving techniques of look at an easy problem, and now let's look at a hard problem and figure out what are the similarities between them, that they'll be able to, again, not need formulas to find these important values, but rather know that each one of the versions of the function gives us important information and to apply that to their teaching, to their learning. So my hope is that if I can go like this, do this approach, and take more of these problem-solving approaches going forward, that I'll be able to, again, not have students be bogged down by formulas and things that I give them, but rather the self-discovery of each one of these. And that way, again, they'll have more of a part in their learning, and that way that they'll go forward knowing a lot more with it. So I hope you enjoy this activity. Maybe it's something you want to look at, and I look forward to seeing your guys'.